Hi, my name is Matt, and this video is about crude oil, gasoline, and diesel, and it's great if you have limited or no chemistry background. So crude oil, it is a mixture of hydrocarbons. My previous video was all about the word hydrocarbon, but if you didn't see that, so hydrocarbon is hydrogen and carbon, two elements bonded together. So carbon likes to make four bonds, and this hydrocarbon is called isopentane. And in these diagrams, carbon is represented by the balls that are black and hydrogen by those that are gray. So isopentane has 5 carbons. Isooctane has 8, and dodecane has 12. So there's hundreds or thousands of different hydrocarbons in any one crude oil, and so I don't want to oversimplify it, but there's too many different hydrocarbons in each crude oil to classify it as, listing off which exact molecules make up that crude oil. So a property that's used very frequently when discussing any hydrocarbons is boiling points. And so the key property is that the boiling point increases as the size of the molecule increases. And so generally, more carbons is going to equal a higher boiling point. So in this example of 3, the highest boiling point would be dodecane, and the lowest boiling point would be isopentane. So each crude oil will have a unique mixture of hydrocarbons. So it's important that if you're producing crude oil in one field, it's going to be different in a field that's offshore in a different state or country. And so companies will produce assays that describe the crude to prospective buyers. And the way you describe the crude is not listing off each individual molecule. It's by using kind of more bulk general properties. So this is an assay that's publicly available. This one's produced by ExxonMobil, and it's for Alaska North Slope. So there's a couple of different properties that you're looking at. The only one I want to focus on right now is the cut volume percent right there on the first line. And specifically, we'll just look at one number. So this 17 right here, this is 17%. And above it, you see heavy naphtha. Naphtha is a word that is usually gasoline range material that refineries and the oil industry use. And so what you would interpret this as is that 17% of this crude oil has a boiling point between 165 and 330 degrees Fahrenheit. So those cutoff ranges are pretty important, that 330 number in particular, because when we talk about gasoline, it normally has hydrocarbons that have boiling points in that range, kind of from a low boiling point all the way up to 330. And then diesel, also a mixture of hydrocarbons in the range of about 330 to 650 Fahrenheit. And then heavy fuel oil is that's higher than diesel range material. So here's 3 different assays and just the cut volume compared to each other. And I show this because you can kind of start to understand that crude oil, it's all different, and you can look at it and compare assays and figure out, how much gasoline range hydrocarbon are in each of these crude oils. And that's a very, very simplified overview of how you would go about comparing different crude oils. So in summary, crude oil, gasoline, and diesel, they're all mixtures of hydrocarbons. And hydrocarbons, they are often classified by their boiling point, and generally the boiling point increases with the size of those molecules, which is the number of carbons. And so crude oil, it's going to have the widest range of hydrocarbon sizes and boiling points. You could have, all the way down from just a couple of carbons, such as propane, butane, all the way up to, very, very large molecules, maybe 70 carbons or more. So gasoline is hydrocarbons with a narrower boiling point range. You're thinking about, it's about up to 330 degrees Fahrenheit. And then diesel is also hydrocarbons, a mixture of hydrocarbons with a boiling point range of about 330 to 650. And just a last reminder, this is simplified. So I'm not trying to say this is all you need to know about crude oil, gasoline, and diesel, but I think it's a good starting point for you to go and learn more now. Thanks.